For this video, we'll get a basic introduction about calculating the area of shapes. First of all, what is area? Area is simply the amount of space occupied by any two-dimensional shape, figure, surface, etc. Examples of the applications of area include finding the area of a football field or the area of a particular room in a house based off of a blueprint. Let's learn the formulas for finding the areas of basic geometric shapes. The formula for finding the area of a circle is pi times radius squared. The formula for finding the area of a triangle is 1/2 base times height. The formula for finding the area of a square is side squared, and the formula for finding the area of a rectangle is length times width, and the formula for finding the area of a trapezoid is base 1 plus base 2 over 2 times the height. So what do the letters in the formulas represent? For a rectangle, L equals length and W equals width. For a trapezoid, B1 equals the length of base 1, B2 equals the length of base 2, and H equals the height. For a triangle, B equals the length of the base, and H equals the height. For a square, S equals the length of the side, and for a circle, R equals the radius. Now let's do a few practice problems to apply these formulas. Number 1, given the figure below, calculate its area. This figure can be classified as a rectangle, and the formula for finding the area of a rectangle is length times width. We're given that the length equals 18, that the width is 9. Thus we can simply plug these values into the equation by multiplying the 2 to find out that the area of this figure is 162 units squared. Number 2, given the figure below, calculate its area. This figure can be classified as a trapezoid, and the formula for finding the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. We're given that the base 1 equals 45, base 2 equals 35, and the height equals 25. Thus we can simply plug these values into the equation by adding the two bases lengths, 45 and 35, to get 80. Then we can divide it by 2 to get 40, and finally multiply it by a height of 25 to get 1000 units squared. Number 3, given the figure below, calculate its area. This figure can be classified as a square, and the formula for finding the area of a square is side squared. We're given that the side of the square is 25. So when we plug it into the equation, we'll plug it in as 25 squared to get 625 as our area, or 625 units squared as our area. Number 4, given the figure below, calculate its area. This figure can be classified as a triangle, and the formula for finding the area of a triangle is 1/2 base times height. We're given that the base of the triangle is 12, and that the height is 12 as well. Thus we can plug the values into the equation as 12 times 12 times 1/2, and we'll get 144 times 1/2, which was equal to 72 units squared. Thus, that area is 72 units squared of the triangle. Number 5, given the figure below, calculate its area. This figure can be classified as a circle, and the formula for finding the area of a circle is pi r squared, in which r equals the radius. So we're given that the radius of the circle is 12. Thus we can simply plug 12 into the equation as 12 squared times pi to get 144 pi, which approximately equals 452.39 units squared when we round to the 100th place. So for number 6, we're given a word problem, a real-life scenario. So, NASA, while working on the creation of its Mars Perseverance rover, needed to design a component that would be responsible for connecting two DC motors within the system. NASA workers came to the conclusion that they wanted to design the component as a cylindrical shape. One of the workers decided to model the component using computer-aided design software. However, he is unsure of its volume. Help the worker out by calculating the volume of the component based off of his model. First of all, how do we find the volume of a shape? Although we haven't covered that in this video, it's actually quite simple. The formula for finding it is pi times radius squared times the height, or the area of the circular surface of the cylinder times the cylinder's height. Remember, we covered how to find the area of a circle. Thus, this problem should be quite simple. Given that the radius equals 3 and that the height equals 20, we can plug these values into the equation, and when we do, we'll get pi times 3 squared times 20, which evaluates to 9 pi times 20, and that will approximately equal 565.49 inches squared when we round, or inches cubed, when we round to the 100th place. Thus, the volume of the worker's 3D model of the component is 565.49 inches cubed. Thanks so much for watching, everyone. I hope you guys enjoyed.